By popular demand, a bit of trigonometry. Everyone's favourite. In trigonometry, everything that we know at the moment is based on what you need to know for A-level. Trigonometry, sine, cos and tan, sine x, cos x, tan x, are based on geometry, specifically a right angle triangle. And we know from GCSE that if we've got a right angle triangle and we've got hypotenuse and an angle, we call this side, which is normally an x coordinate, horizontal distance, and y the vertical distance. We tend to call this adjacent to the angle, opposite to the angle. Hypotenuse is always along the side, so it stays hypotenuse. So what we'll do is consider the case where the hypotenuse has a length of 1. And we know that sine theta is defined as opposite over hype, from SOHCAHTOA. So is sine op hype, and that's equal in this case to y divided by 1. Well, when we divide by 1, we don't change anything, so y is the sine of theta. So we can replace that and call it sine of theta now. And x, by the same token, we know that cos of theta is edge over hype, and in this case it's x over 1. Same thing, y divided by 1. So x is the cos of theta, and we can replace that by cos of theta. Okie dokie. So we know that tan of theta is equal to op over edge from SOHCAHTOA, tan op edge, and in this case that's y over x it used to be, but now it's sine of theta over cos of theta. And that's our first identity, ident 1. And we can test that. Let's have a look at tan of 41.3, random angle, shift mode, angle unit 1, and we've got tan of 41.3 is equal to 0.8785214.661, and sine 41.3 divided by cos 41.3 is equal to, so guess what it's going to be, 41.3 divided by cos 41.3 equals, oh look, it's exactly the same with that. That's random, you can choose anything, it's always going to happen. And then we have the next one, and that goes back to Pythag, and it's actually called the Pythag Trig Ident. This is a special one. This is the thing that links trig with Pythag. It's Pythagorean trigonometrical identity. Too many syllables, too many letters. I'm writing that down. And this says that we know that x squared plus y squared equals hype squared. So in our special case, if you like, we've got sine squared theta for y plus cos squared theta for x squared, and that's equal to 1 squared. So this is ident 2. And we can test that one out as well. Let's use a different angle. Let's use 36.92. So sine squared of 36.92 plus cos squared of 36.92 is equal to, can you guess what it's going to be? Right, what this means, sine squared of something, is that we do sine of 36.92 and then we square it. And this is going to be cos of 36.92, so we should put that in bracket too, 36.92, and then we square it. That's what it means. We write sine, then square that, because if we write this, and people get lazy and forget, or just don't bother putting brackets in, then it gets confusing. So we don't write this, we just write that, but this is what it means. Okay, so let's put it in brackets to make sure that everything can handle it. Sine of 36.92, and put 2 brackets on and square it. I'm going to add bracket cos 36.92 bracket square it. When we press the equals, it should be 1. Oh, weird that. Okay, so the question that most people ask is, what if it ain't 1? What if it's 2 or 3? Let's do 5. Well, if this is 5, all I've done is scaled up a smaller right angled triangle with a hypotenuse of 1. I've multiplied by 5. I've done a scale factor 5. So this is going to be 5 cos of theta, and this is going to be 5 sine of theta. So when I do tan of theta, the opposite is 5 sine divided by the adjacent, which is 5 cos. Guess what happens to the 5s? Yeah, they go away. So it's always tan of theta is sine of theta over cos of theta. I tend to say tan is sine over cos, and we understand the angles are the same. And similarly, if we replace in this one, or this one, the hypotenuse is 5 now, we'd have 5 sine theta as our side square it, plus 5 cos theta as our vertical side square it, equals 5 squared, which is 25. But when you square this bracket, we get 25 sine squared theta plus 25 cos squared theta equals 25. Guess what we can do with the 25s? Yeah, they all cancel out. Divide both sides by 25, and we get sine squared plus cos squared is 1. Piece of cake. So there's our two identities.